Section 11.8 Aromatic Compounds. In 1825, Michael Faraday isolated a hydrocarbon called benzene, which consists of 6 carbon ring with alternating double bonds and has a molecular formula of C6H6. He isolated this as he was studying this in England as some of the lamps as that were lighting the roadways. Now, in this particular section, our learning goal is to describe the bonding in benzene, to name the aromatic compounds, and draw their line angle formulas. Now, benzene is considered an aromatic compound, so let's figure out what aromatic compounds are. Aromatic compounds has a ring of, for example, like benzene has a ring of 6 carbon atoms, each bonded to 1 hydrogen atom. It is drawn as a flat ring structure, drawn with 3 alternating double bonds. It's represented by 2 structures here. Notice here, so the first thing is, as we look on the far left here, and in one way it can be drawn like this. Okay, now then, a more accurate way, but it's not the totally accurate way, is to draw it as 2 structures in resonance form, this double-headed arrow here, and you will notice that it is represented by 2 structures here because the electrons are shared equally among all carbon atoms. So you'll notice by having it this way and then this way, it shows that, oh, on one hand the double bond is here, on the other hand the double bond is here, 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 here. But in all honesty, the molecule does not go back and forth between it. It's actually more of a blend, and so a more accurate view is this picture here, which is the second from the end, which has, it showed that the electrons are shared equally over the molecule. It's represented here by this skeletal formula using a circle in the center instead of the alternating double bonds, because it really isn't true alternating double bonds, but more like a blend, where the electrons of the double bond are shared equally across the molecule, essentially making it where all carbon atoms have 1.5 bonds. Now, this makes the molecule very stable and not susceptible to the addition reactions we learned back in the last section of normal double bonds. Now, since it does have hydrogens, 1 hydrogen on every carbon atoms, and quite often when we build stick molecules, we don't show the hydrogens, we'll notice right here on this far right is the more common designation of our benzene molecule. So when you see this, it looks like cyclohexane with a circle inside. Do not call it circle cyclohexane, because it's not. This is a representation of the benzene molecule. So when you see this item right here in the bottom right hand side, that is benzene. Now notice, for the next little bit, I'm going to be having this molecule up here, benzene, so it's right here in front of us, so that you get used to seeing this molecule and you recognize this as benzene. Now, benzene is carcinogenic. It causes cancer. And you go, oh, well, I don't want any benzene around me then, because it causes cancer. It's not just a suspected carcinogen, it is one. Well, let's see. I wonder where benzene is. Oh, well, in our gasoline, it makes up 30 to 40% of our gasoline. And so, you know, the stuff you pump into your car, about 30 to 40, about a third to close to a half, but a third-ish has benzene in it. So if you're sitting there breathing the vapors, that's not good, because you're then inhaling benzene, which is a carcinogenic. Or let's say that because it's such a good solvent, because it is nonpolar and it dissolves other nonpolar items, it makes a great solvent for like grease. Let's say you got something greasy and you want to dissolve the grease, and you go, oh, I'll just put gasoline on it. Well, and I'll just squish it out with my hands like an air filter. I'll just squish it out. Let's say in the olden days we'd do that with the air filter with our little motorcycle, and we'd squish it out. Well, that was pretty crazy. Of course, back then we didn't know that our gasoline had benzene. I know that the scientists and the automakers knew it, but we didn't. Okay, but when we'd squeeze out the the oil out of the air filter for our motorcycle, we would do that with the gasoline and put our hands in there and stuff. And that's not a good idea to do that. But it did work great because it was such a good solvent for other items that you couldn't normally get to dissolve in water. But do not do that. Now, benzene rings can also be fused together. So let's look at this benzene ring here and another benzene ring. Some of the fused benzene rings are carcinogenic, and they have a particular name for them: polycyclic aromatic hydrocarbons, otherwise known as PAHs. Okay, so polycyclic meaning more than one. So here's our benzene ring, this molecule here. So here we have more than one benzene ring fused together, polycyclic, and they're aromatic hydrocarbons. So here's our naphthalene, which if you go and buy mothballs, there's naphthalene. Mothballs are made of naphthalene. Well, most of us here probably don't buy mothballs because we don't put sweaters in the closet. But back in the Midwest, they might put mothballs in the sweaters in the closet or whatever, just to keep the moths from eating their sweaters. It kills them off. Well, they're carcinogenic, so really, do you really want to have mothballs in your closet seeping through your house? The vapor seeping through the house? No. So here's another example of a PAH, a polyaromatic hydrocarbon. Let's see, in this case, we have 5 of them fused together. Now this is 3,4-benzoapyrene. It's also carcinogenic. And you go, well, I'm going to stay away from that. Well, let's see where that's found. It's found in tobacco smoke. And you go, oh, well, I don't smoke, so I'm okay. Well, if you like to grill and if you char your meat, well, then the charring has the benzoapyrene. And so please don't eat the charred portions of your meat that's grilled on the barbecue, because it has this carcinogenic compound here that's found in tobacco smoke and automobile exhaust that you're probably doing a really good job of staying away from. But if you're then just going and cooking on the grill and eating all the charred portions of your meat, well, guess what? They found that people who do that have a higher rate of stomach cancer, by the way. So, I'm not saying don't grill your meat. I'm saying don't char your meat. All right, naming aromatic compounds. So, aromatic compounds contain a benzene ring and a single substituent are named as benzene derivatives, and they quite often have their own special common names, so you need to know them. So here's benzene with a methyl group. We're not going to call it methylbenzene because this has its own special name, which is toluene. So when you see this on an exam, if you write methylbenzene, you are going to be counted wrong. It is toluene. Okay? Over here, we have another one, aniline, which has our benzene ring and a nitrogen and hydrogen. Over here, for our final one, phenol has our benzene ring and an OH and an alcohol group on there. Do not call it alcohol benzene or benzene alcohol. No. It has its own special name, phenol. So when you see this on the exam, please don't write alcohol benzene. It is called phenol. Now you go, well then, those had special names. Do all of them have special names? No. They don't all have special names. So let's look at this one. So this is just plain, we know Cl is chlorine, and so we'll just name this as chlorobenzene. And if we have 2 chlorines on our benzene, then we got to name where they are. Why? Because they could be in different spots. So we call this 1,2-dichlorobenzene, 1,3-dichlorobenzene, 1,4-dichlorobenzene. Now when toluene, phenol, or aniline has substituents, notice how they are named. Since these have their special name, then they are the boss, and everything is named after, with it being the number one. So here's our aniline, the NH2 with the benzene ring. So if we have bromine and we have it in the 3 position, we don't have to say 3-bromo, 1-aniline. We don't, because it's understood that aniline's the boss, and so that's where the numbering starts. So we're just going to say 3-bromo aniline. Now here's our OH on the benzene ring, so we know that's phenol. Now then, so that's where the numbering starts if we have other substituents on here. So we are going to have it where the numbering is the lowest numbers. So we are going to number, in this case, counterclockwise to put the chlorine on number 2, rather than going around the other way, which would put the chlorine on the number 5. So when we do this, because we alphabetize and B comes before C, then we're going to number counterclockwise, and then when we name it, our bromine comes first because it's alphabetized. So 4-bromo 2-chlorophenol. Now here's toluene, which is the benzene ring with a methyl group on it. Toluene. So because that's toluene, it's going to be the boss, and we're going to name everything in comparison to where the toluene is. So we'll start our numbering and go this way, and so we have a bromo on the 2 and a bromo on the 6, and because B comes before C, and remember dibromo is not alphabetized, so we have 2,6-dibromo 4-chlorotoluene. Alright, so I need you to be able to identify the common, like, what is it? Is it an alkane, single bonds? Is it double bonds? Is it triple bonds? Or is it an aromatic compound? You need to be able to identify these. Well, let's look here. I'm hoping that you see on B that we have our double bond, so that's an alkene. I'm hoping on C, you look here and you see this triple bond, so that's an alkyne. Now, you may be tempted to look at this molecule right here on A and go, oh, well, we've got some double bonds here, alternating double bonds. That must be an alkene. No. This is our aromatic compound. Remember how they sometimes write our 6-membered ring with alternating double bonds right here? Well, when they do, that is our aromatic compound. That's our benzene molecule right there. I wish they would draw it with, like a circle in it, but they don't always do that. So you've got to be aware of that. So this is our aromatic compound. Now, toluene is used as a reactant to make drugs, dyes, and explosives like TNT. I know we've all heard of TNT. Have you ever wondered what the heck TNT was? Well, guess what? Trinitrotoluene. So here's our toluene molecule, our benzene ring with our methyl group on it, so that's toluene. And we have 3 nitro groups on it, hence trinitrotoluene. Okay, here's our acetaminophen, and notice that we have, here's our benzene ring, and we have our other items. Now, just because it has a benzene ring does not automatically make the molecule carcinogenic when the benzene ring is part of something else. So don't just go, oh my goodness, my acetaminophen or my aspirin or my vanilla is all carcinogenic. No, we can't just automatically make that jump between the two. But I did want to point out that our aromatic compounds are an important aspect of making our different molecules. And then you go, well, wow, so where do we make our aspirin or acetaminophen from? Well, that's actually an important part of our hydrocarbons, is being able to make our medicines and drugs from our hydrocarbons. So you'll notice our concept map, Introduction to Organic Molecules.